Hello? Okay, so we have to restart the system because the previous professor using some wireless device is just completely disconnected with our computer. So we just wait for 1 or 2 minutes. When the system completely shut down, we reboot the system, probably will work because I think the previous professor somehow used his own wireless. Then it will not be able to connect it to our computer now. Okay. Yeah, we will probably take 1 or 2 minutes. Before that, I should warn everyone is our programming assignment, the homework number 3, which is a programming assignment, is already available. I did got one student. He sent me email, said he did not even know the second assignment due was last Tuesday. He was thinking next week. So he did not do it at all. Then he asked what we can do. I told him I start last Thursday and also this Tuesday. Keep warning everybody the homework was due. You have to work on it in a very substantial way. But unfortunately, the student said, I did not watch the video. I did not attend the class. I did not know anything about it. And that's not a good excuse, I probably should say, because obviously we know, everything we already follow the line. Okay, so I just restart the system. Hopefully this time it will work. Another thing I should give people enough warning beforehand is our midterm exam. Okay. The midterm is next Thursday, October 13th. And we will start 5 minutes earlier. It simply says you should really come a little more than 5 minutes earlier. You sit here, sit on the appropriate one. I will announce the seating scheme because we will calculate how many people really will take other exams. Suppose we have some disability students, they may take additional exam. We do have 3 or 4 students. They could not make this exam. We arranged 1 day earlier. That means instead of October 13th, we arranged October 12th. The time actually is 1 to 2:30. Okay. I just warn everyone again. Okay. The time alternate exam is time 1 to 2:30 Wednesday, October 12th. Okay. If you really have some specific reason, you cannot make the October 13th exam. You should let me know, let TA know immediately. We can arrange you go to October 12th exam. Okay. And we do not plan to have too many other exams. So you probably know this. Then, we need to make sure you really, can get into this one. Let me see whether we can really get it work. Okay, now it really works. I think that's great. After we reboot it, I think we can do it. Okay. The first thing I still want to mention is the assignment number 3. Okay. The assignment number 3 is a programming assignment. It is on frequent pattern mining programming. We distribute it on Tuesday, and the due is almost like exactly 1 month from the distribution time, October 4th. So you should closely watch the due date because programming assignment usually takes longer time than the minor calculation, using the numbers or calculators. Okay. And this assignment also, we said it counts 10% of the final grade. That means weights double. Okay. Weights more than the homework assignment. You should treat it seriously. This one is really using the frequent pattern mining, but it's on the real data sets. The real data sets, we actually give you the real data sets. We give you actually it's data sets published on the DBRP, which is a computer science research publication database. Okay. And what they have, actually the real DBRP has more data. We just projected two things. One is a paper ID, another is the title. We only want you to look at these two fields. Essentially only want you to look at the title. The authors, the conference or journal names are all gone. Okay. What you need to see is just this title. And we also, to make sure you do not get a too big data, because there are over 2 million papers in the real database, we only pick up 5 domains: data mining, machine learning, database, information retrieval, and the theory. Theory means algorithms. Okay. We pick those real data sets from the real database. Okay. And what we want you to do is try to do some mining using this frequent pattern mining methods. And finally, you may find something pretty interesting. Okay. But you do not really directly download from the real database like the ERP database, because it's too big. It will take more time to process it. Plus, every day the new paper is adding in. We don't you to get different answers. Okay. So what we do is we provide you the real data sets. You can click the button, you can get it. Okay. See, you can first click this one. You see the real data sets. You can download it and see it. It's very big. Okay. You probably can see those are the real data sets. Okay. But we did a little pre-processing. So-called pre-processing is we remove those stop words like a for, off, those kind of things. Okay. And we do a little stemming. Stemming means they have slightly different thing. You probably will collapse them to be the same thing. So it's easier to mine, easier to get patterns. Okay. So that one, you perceive that's a raw data you can see. But we do have the real data you can download here. You can download the real data sets. And then you are going to develop some algorithm to mine it. Okay. That's the one we give you step-by-step, how to partition the data, how to mine the data, finally what's the output we expect you to generate. Okay. So it's an interesting one because you see the real life, how do you do the mining, and why this mining will be useful. But it will devote you more time. So you should read the whole document carefully. I'm not going to go over this document so carefully. But on the other hand, there are some tools you can use. For example, we told you you can use LDA packages. How exactly this LDA works? Okay. LDA means latent least allocation. Okay. But we are not going to teach this. If you came to this lecture, I think 3 weeks ago, Professor David Bly, who is one of the major inventors of this method, actually, when he was in maybe Berkeley or Princeton, he actually invented this one. You are not going to understand what's going on. You just run this package, you get some results, then you can do the pattern. Okay. So read this carefully, you play with it. If you need help, you always can come to my office or TA's office, ours, and also you can put some general interesting question in Piazza. Okay. If you find anything you cannot go, you really encounter difficulty, you should contact us earlier. Okay. Maybe some instruction here was not detailed enough. Okay. then you give us warning. We can revise it correctly. Okay. So I should say start early. And you play with it, you run it, you encounter any problems, contact us. Okay. So there are different partition on the points, like a mining frequent pattern on each topic, and mining max and a close pattern, okay, and also read rank by purity of the pattern, and we even have bonus points. Bonus points means you have additional time, you want to do more things, you can play with those bonus points. Bonus points actually have some published papers you can read. Those are the papers by our previous PhDs. Like a Cassie was developed by Zhi Wang, now he's in Microsoft Research. Kurt was developed by Marina Danievsky, and she actually now is at IBM Armaden Research Center. But they actually have the research papers you can read, and you can play with their methods and see whether you can do some bonus. So this is about the programming assignment. So any questions related to the assignment? Yes? Yeah, how big the data set is. The data set, it depends on what standard you say how big. In principle, it's not too big because you think about this. The total titles for the whole DBRP is about 2 million papers. But once we say we only get these 5 sub-peers, 5 domains, essentially it's only like 10% or less than 10% of the whole DBRP data set. And we also remove a lot of things, remove the authors and venues, and we remove lots of links. We only take the title, and we remove the stop words and the stem it, so the data is substantially smaller. But it is not like a toy. Okay? It's a real thing, so it has some substantial size. But it won't take that much time to go through. You won't need a very powerful machine. Using your laptop, you can run it. Okay. Whether it's a couple of hours or not, running LDA will take some time because of this latent issue allocation. The generative model takes some time. But once you run through LDA, you've got the data saved there. You run the pattern mining again. It won't take them. Okay. So the LDA, I expect you only run it once. Then when you play the pattern mining different algorithms, you can run many times. It's really fast. Of course, you have to use the efficient pattern mining. If you use something really slow, that's your problem. What other questions? Okay, hopefully you can start early, and you can shout in Piazza, if you need help. But at the last minute, if you say, I only do it in the last night, then it will be, okay, you will never be able to start early. So for programming assignment, this is definitely remember, we actually have 2 programming assignments. This is the one. Assignment 4 is another programming assignment. There are 2 programming assignments. It counts 20% of a grade. It's non-trivial. Then the last one, we will give you the homework again because I don't want to torture in the final exam period. So we get 2 programming assignments right in. So hopefully you will enjoy it. Once you know it, you play with it. A lot of people enjoy it because they found it's useful even later in their work. Okay? They found it in the real data sets like this is large text data you can play with. So I think last year the Coursera, the course, they do the Yelp data review. Okay, there are thousands of people playing this. They really enjoy it. Actually, lots of people they say it's really great. It's related to their own work. They have to handle lots of data, like Yelp reviews. They can play. They know how to mine. So hopefully you will find it's useful. Now we come back to the lecture again. Last time we said the patterns you want to mine, actually there are lots of different kinds. One is mining compressed pattern. This because when you mine very large data sets with many different transactions, very likely you will encounter problem is the pattern you mine is just too many. Actually, many of these patterns are sort of redundant in the sense you can easily compress them to make the number of patterns much smaller, but you do not lose much information. The easiest one I can show you here is like P1 and P5. The P1 is a sub-pattern of P2 because P2 is a little longer. But they share many very similar support. That means their occurrence frequency is very close. That means almost every time you got into this long pattern, the short pattern also appears. Only sometime this longer pattern, is the shorter pattern is a little more frequent than the longer pattern. Then this is something you want to compress them into just P2. Okay. And I will give you the formula. The formula essentially is saying this one is very much like a Jacob coefficient I said. That means actually the transactions, they share a lot. You can see these are the share one. These two patterns, their transaction ID, once you intersect them, is almost same as you unit them. That means almost the two almost appears like a very similar, almost appear concurrently at the same time. Okay. Then this distance will be very small. The extreme case means their intersection and the union is exactly the same. That means the pattern actually the two patterns occur exactly in the same transaction, same kind of transactions. Then they almost, this actually is like the close pattern. Because the larger ones, shorter ones, they occur exactly the same number of frequency. They are closed. If it's closed, actually 1 minus 1 is 0. It's actually 1 covered here. But if they are not strictly closed, but they are very close, then their distance is very small. Means you actually can use a delta as a threshold to cut those patterns, which actually have a very minor difference. You only reserve the longer one. Okay. So there are some efficient algorithm mining, but this one is a good definition. Essentially, it's the two kinds of patterns, they overlap in their occurrence so much. You only need the longer one to show up. Then, for the same author, Dongxing, actually, he worked out almost a similar time, work out called redundancy-aware top K pattern. The first thing is about top K. What is top K? That means you get lots of patterns. Most managers or people not precise. They say, I don't want you to show me thousands of patterns. It's too much. What about you show me the most important 10 patterns? So this K, now if you say 10 patterns most useful, most important one, becomes top 10. K equals 10. Right? The redundancy aware means, of course you can say the most important one is the most frequent one. I show you 10 frequent ones. Top 10 is based on frequency. But we already know, just to look at those things, you already see. The frequency sometimes does not be that important. For example, P1, P2 are all both very frequent. But P1 does not contain much information. So rather than just based on the frequency gave top K, I say this one is almost covered by P2. I don't show this. I show P2, P3, P4. Actually, they are not the most frequent one, but they contain lots of useful information. So that's redundancy aware. Because we know this P1, P5 like redundant. Why we have to show? So the same philosophy. Now we think about it. If you say show top K, actually I want to find a meaningful top K and give it to you. what is meaningful? You look at this picture, you can see. The first thing is the darkness of this one means the significance. Maybe you can think it's the most frequent one. The more frequent one, the darker. You can think in that way. Then you also know we should not just give you the most frequent one because there's something very similar why they give you those redundant. So the redundancy, we are basically thinking about it. We want high significance. That means maybe more frequent. But we want a low redundancy. That means they almost covered by the others, what I have to show you. Right? So we can think about the redundancy can be mapped into a map or into a two-dimension picture. And you will say redundancy means they sort of forming the same cluster, like this. They form the same cluster. You will say they are largely redundant. Then it becomes whether you want to see just based on the significance or you say frequency. Like the C actually is just show you on the frequency. Then you perceive these frequency, I show you these things actually may not be that good because they largely redundant. Like these two are so close. It's more like our pattern like this one. P1 and P2 so close. Why I have to show both of them, right? So I just show one. That means if you think about this top K just based on frequency or based on significance, actually it's not that good. I mean, show this is very dumb because people cannot see other kind of interesting things. Right? So another one, this D is based on summarization. That means based on clustering. You can say, oh, here is a cluster, here is a cluster, here is a cluster. I find 3 clusters. None of them are mutually redundant. These 3 clusters are all important. Then I find the cluster centers. I show you the cluster center. But you probably see you miss the top K, the significance. The best one is you integrate both kind of a clustering, the summarization, and significance. You may think about it. Both of them are very important. Then you may likely finding things like this. This shows there's a bigger cluster, but you have 2 significant points. They are far apart. You probably want to use 2 to represent them. Okay? Then you use this one to represent the other cluster. This third cluster probably because none of the points are very significant, you probably can drop them. So if you only have chance to show 3, you may show this 3. Right? That means you have to consider both summarization and significance. That means you have to thinking about low redundancy and high significance, both criteria. Then you can get things like. So with this, actually he worked out one, say maximum margin significance. Then you combine these 2, like combine significance and redundancy as an integrated measure. Then you can find redundancy aware object. I'm not going to give you the detailed formula, but just give you the idea. In reality, you have to think about it. People give you a top K, you have to think about it. It's not just based on frequency. You have to consider redundancy. You want to get it. High significance and low redundancy. Finally, the top K pattern is the best. So that's about 90 patterns. Remember, in reality, you will find lots of patterns. In real life, people ask you to find patterns. Just use support and confidence. You'll find lots of them. Remember, I give you a sample exam. Okay. Sample exam just give you a tree. But once you get a tree, you map into rules. You may find there are lots of rules. Okay. So that's exactly why this redundancy is something you have to think about. Otherwise, you just create too much. Now we get another topic is constraint-based frequent pattern matching. What is constraint-based frequent pattern matching? Actually, this is very rare in the sense Most people, you say, go down to database, or go down to transaction to mine patterns, you generate lots of patterns. But people actually always want to find certain things. They put a constraint there. They're thinking about the constraints. The typical constraints could be, one thing is constraint on data. You say, I'm only interested in Urbana-Champaign data. I don't care Chicago, I don't care New York. So that could be one constraint for data constraints. You constrain, say, this month's Urbana data. Okay. So that's constraints on the data. But you also make constraints on the patterns you want to find. For example, you may say, I only want to find those items I want to promote actually worth $10 or more. If it's only less than $1, I don't even bother. Right? So you may want to look at those worth more money. Those are the constraints. So the constraint mining, the general philosophy is, I give you constraint beforehand. Okay. You need to use this constraint effectively to push the constraint deep into your mining process, because mining could be expensive. You wait there for hours. But if I give you constraints, you use it, maybe within seconds, okay, you can get a result, because my constraints are almost focused. That's the same as you go down to bank machine. Okay. You want to see the balance, but you don't want to see everybody's balance. You want to, extract money, say $100 from your account, not from other people's account, right? So that's why when you insert your bank, your bank card, into this cash machine, actually this card, remember this bank contains thousands of people, thousands of customers. Once you insert this card, you know what things will do? Okay. Of course, they will say, oh, enter the PIN. Actually, once you insert the card, the bank already become very smart. They look at your card ID, look at your customer ID. They immediately go down to the big index of the bank, of their bank. You insert card, they actually will take your record. They don't take anybody else. They take your record. Then when you type the PIN, they just map your record PIN. Then they start saying, do you want to check balance, or do you want to withdraw money, or something like this? Remember, constraints always go first. If you insert your bank card, that's a constraint, your ID. The bank immediate response, they only take your account out. So that's the smartness. That's the importance of pushing constraints as deep as possible. They don't want to search anybody else, right? So that's the same thing as mining. Okay. Then we look at the constraints in mining, what kind of constraints we really have, and how we handle it. Okay. That means if you want to mine anything, well, for example, you work for Walmart, you want to mine the Walmart transactions, you give a data mining query. That means you're not going to say, I want to see everything. Okay, that's usually not real. Okay. The data mining query may contain many kinds of constraints. One constraint we call knowledge type constraints. Knowledge type means you want to do classification, or you want to mine association, frequent patterns, or you want to do outlier finding, or clustering. That's the first thing. Of course, for us, we only studied association and frequent patterns. That's the one we want. Right? Another one is data constraints. That means what kind of data you want. You want to say find a product sold together in New York store in this year. Okay, that's the time, location, and all these are the data constraints. Then the third thing is dimension level constraints. Dimension level means what things you want to relate it. You want related to region or price or brand or customer category. Those are the things. But what we really, in this lecture, we are going to study is rule of pattern. That means you give some kind of rule of pattern. For example, you say, I want to find those kind of things. Like small sales trigger bigger sales. For example, in many stores, they give you a coupon or give you an advertisement. Say, my banana today is only like 20 cents a pound or something like this. Then why they do that? Actually, sometimes it may even below the cost. Right? Because their banana maybe cost 30 cents. but they sell 20 cents. Why they sell this? Of course, they know you are not going to get a truck of banana, back there, going to lose money. They're thinking you will get just a small bag of banana, maybe only 2 or 3. So you go to their store, you drive down there, you are going to buy other things. The other things, probably regular price, they push sales, right? Those are the things they say they want to have small sales, like even below the cost. Okay? But they want to trigger bigger sales. If people go down there, if they just buy banana, you lose money. But on the other hand, they're going to buy a lot of things. They may buy $100 in a car. Then you really will get a good profit. So they may want to find those kind of rules. So what kind of thing I put on sale, I will trigger the wholesale. Right? So that's the constraint they can put in. Like you go to Meyer, the Meyer company, the boss may want you to find those kind of things. They know what things to put on sale. Right? And another thing, of course, the constraints, like you said, I need a minimum support, minimum confidence, minimum correlation, or something you can put down like this. Remember, okay, I just got one person put on Piazza said he actually checked our sample exam. We get this tree to find the rules. He says, I only learn in the frequent pattern mining, only learn how to put minimum support. I actually do not know where to put minimum confidence. Remember, once you get patterns, you want to find the rules. Say, A implies B. That's the time you need minimum confidence to put it down. Okay? Something not confident, you don't want to show it. So once you get support, ABC, that's a support. Then you get AB. Then you can have AB implies C. You can get the support computed by just divide the two minimum support, you can get it. So you can go back to the slides, you can watch it. For sure, for midterm exam, we're asking you to get the rules to have both minimum support and minimum confidence. Otherwise, you just get too many. We want to restrict the number of answers. Give you easier time. You have to set up. Okay. So you watch it out, you have to understand this. Now we get into the real rule, mining. People put down some kind of rules, you want to get it. The first kind of rule mining is people call meta rule guided mining. Meta rule guided mining means this. Okay? I put a rule like this. Say, find rules exactly in this shape. Okay? And actually, this shape, they may even put some constant. Of course, they may not put any constants. That means you find everything in this shape. As long as they support minimum confidence, you have to show it. But this one actually is more restrictive. You have to use it. This one said, I want to find, suppose X is the customer. Okay? The customer, suppose the P1, P2 may be buys, maybe other things. Okay? If you think P1, P2 is buys, what they want to find is X buys this, Y, X buys W, then X buys iPad. You want to find this rule. So that definitely makes sense. Sometimes they may even have other predicates they want to find. For example, you may find X, this P1 means age. Okay. This P2 actually I found is profession. That means if X, the age is between 15 to 25, the profession is a student, the X will buy iPad. So, of course, there are certain supports of certain confidence. You will find this rule that makes sense. Of course, you may say, if X age is 15 to 25, this one buys, they suppose buys iPhone. Okay, then you buy iPad. Those are also rules matching this meta pattern. If you really have this, you have to show it. So how to mine this meta pattern rules? Of course, we have an algorithm, but in principle, you can derive this algorithm efficiently. The first thing is you have to find this predicate length is 3. You can see this is one predicate, this is another one, this is the third one. You need to find left-hand side plus right-hand side. This total number of predicates should be over the minimum support. For example, you say this one is 20 times. You are going to kill this rule. And how do you get 20 times? You have to think you have the predicates 1, 2, 3 getting together. These 3 items getting together must be over 20 times. Then you are good. Right? So that's the first thing, is finding those frequent items, frequent predicates. Then push those constants deeply into the process. Actually, you can even modify the algorithm. You can say, I actually can do it better. How can you do it better? You push this iPad inside it beforehand, right? You can think about it. This push constant deeply when possible into the mining process. If I would do this, I would say, first push this one deep, then I find frequent pattern. Definitely it's more efficient. Think about it. It's more like you first put your bank card into the machine before you say ask the bank to do anything. Because the bank doesn't want to put all their accounts there. You put your bank card there, you only find your related stuff. It's more efficient, right? So that is a constraint pushing technique. We're going to study more detail. Then you can think about how to use minimum support, minimum confidence, minimum correlation, and all the other measures. Those measures you usually, after finding those patterns, you can cut using confidence and correlation. Now we get into the rule one. That means I really have the rules, like something like a constant or something like this or something. I really have those things. How I can push in, whether anything can be pushed in, or I have to be conservative to push something in, something not in. Actually, this is the trickier than query processing. Why is it trickier than query processing? Query processing usually is just SQL. You can push the constant in many different ways. But this rule mining is you have many iterations in the process. Like you find a frequent one, then you go down, you find frequent 2, frequent 3. You have many, many rounds of searching a database. That becomes more trickier. Okay, if you think of this. That means you have to think about where you dare to push in or not push things in. Okay. Then we study these rules. We say what things can be pushed in your mining process once you give me the constant. Okay. So actually, this whole thing you perceive, every one is a technique. We have to introduce you quite a bunch of techniques to really solve this problem. Okay. The problem, we partition them into pattern space pruning and the data space pruning. That means you give me something, either I can prune the pattern space. That means the pattern going to generate, as I don't generate anymore, this pattern should be thrown away. And even the subsequent process, I'm not going to use it. If you prune it easily for this pattern, I'm not going to look at it. Okay. So that's a pattern space pruning. What is data space pruning? Data space pruning means if when I'm doing the mining, I found this part of data will not be useful. I actually can chop it. Say, remaining process, while I go, this kind of data will not be useful. I make my data much smaller. So let's see why we need to study this, why this one is not so big. Okay. Let's look at the first one. The first one, if you look at this, you see what we got is anti-monotonic, monotonic succinct convertible. You read those words, you know what it is. But it will be in your midterm exam, okay? So I should say the midterm exam will cover things, at least, today's lecture definitely will cover. Okay, whether we will cover the next Tuesday or not, it depends. I actually intend to cover this section. We finish it. Probably the remaining section we can put in the final exam. Okay. But this constraint pushing definitely will be decided. Now we first look at the first one, is pattern anti-monotonicity. Okay. What is pattern anti-monotonicity? Let's first give you the real data sets. But even real, I would like to write A, B, C, D, E instead of say this is the apple, this is banana, this is the coffee, because it's too long. Right? You just assume those are all things. You can think A is apple, B is a banana, C is coffee, D is some dairy milk or whatever. Okay, you can think all these are the items in your transaction. These are 4 transactions. Okay. But here I also put profit there. Okay. Why I put a profit, not put a price? Because you perceive the profit can have a positive number, can have a negative number, because in the real data you may have positive and negative number. If I put it just a price, everything is positive, you do not see like a zero and negative value. It's not complete. That's why I put a profit here, so you understand. In the general case, you should have positive. Okay. Now, I first look at the example before I give you a definition of what is anti-model. So the first thing is this. Okay. Suppose I give you the constraints like this. I say, this S is your item set. You want to find a pattern like A. If you buy that diaper, like you're going to buy B or something like this. This S means diaper, coffee, nuts, okay, all these things. But they have one thing is price, one thing is profit. The difference between price and profit, already told you. Price must be non-negative. I think it should be positive. Right? If it's free, of course, it's possible free, but they definitely don't give you additional money to buy stuff. Right? Otherwise, you'll buy all. Right? So, but the profit can be positive and negative. Now let's look at this. This one said some S dot price is less or equal than some value. The value may be $100. This value is just $100. This one says, I want to find this set of item sets, these frequent item sets. Their price adding together is less than some dollar. Less than some dollars. You can think, what's the use of it? Maybe the manager may want to sell bananas and some cheap items, want to promote sales. But he doesn't want to lose money. He just say, oh, all these sale items adding together should be less than $100. Otherwise, they go down there, they only pick up sales items, I may lose money. Right? They may have this kind of thing as their pattern they want to find. So it does make sense. The problem becomes when you mine this pattern, because there are so many items in Walmart, right? When you mine this pattern, you have to know when you are going to stop. If you think about it, you keep mine in a transaction database. Every shopping cart has pretty many items. It will take many rounds. Finally, you will find you'll finish mining. But if I say this one must be less than, say, $50, okay, you can stop somewhere. You say, don't mine anymore. You go further, I don't want it. You know when you can do it? You think about this. Suppose this one is $50. B is $50. Every price may have $10, $5 or something, okay? When you can stop. You say, don't mine anymore. Don't go down anymore. Because you go down more, you will never satisfy my constraints. Anybody can tell me when you should stop? You keep adding things, getting your patterns, when you can stop. Anybody can tell me? I think it's very simple. When you can stop. Anything while you mine it, you sort of like adding this A into my pattern set, adding AB into my pattern set, adding ABC into my pattern set, when you can stop. Remember, if you think about this, suppose this one costs $20. The other one costs $40. Suppose A is 20, B is 40. You put it in. Should you stop? You should stop. Because A and B adding together is already $60, right? $60, if you put the constraints less or equal than $50, it's already over. You add more things into this basket, you know nothing is negative price, right? So you add anything there, you are not going to satisfy this constraints. That means once you fail this constraint, once you violate this constraint, adding more things you are never going to satisfy. Is that true? Right? You think about it, this is very simple, right? If your basket already $60, you say, I only have $50 cash. You are at $60. What people will suggest you take something out rather than adding more things in, right? That's obvious. So that's a very, very obvious constraints you can do. And we call these constraints anti-monotone. What is anti-monotone? Anti-monotone means once this thing, this item sets, putting in, violate this constraints, stop. Don't go anymore, because you add anything more, you will keep violating constraints. You will never satisfy. Right? This is common sense. Then we say this rule, actually this rule you can see is very general, because S can be any item. This V can be any value. But this one is anti-monotone, means if you put this rule there, anytime your current shopping basket or item set, this set, violate this constraints, stop, throw it away. Because you never get set. It's very simple. That means, what is anti-monotone? Means if item set S violate the constraint C, this is the constraint C, C1. Okay. So does any of its superset. It means you don't add anything in, because adding anything in, you will never be able to satisfy it. Forget it. Throw it away. Okay. So that's the first rule, is anti-monotone constraints. That means the mining of item sets X can be permanent. You just throw it away, it's violate your constraints. You add anything in, to violate your constraints, throw it away. Okay. Then we look at the second one. Second one said a range S star profit less than 15 is anti-monotone. Do you agree? Range means this is a profit. Profit can be positive and negative. Remember, if you change this one to profit, I dare not to throw it. Because I can add something, actually have a negative profit. Like I add a banana in, actually the profit will be reduced. So, if you say less than $50, I still can add something. Anything negative I can add, right? But a profit range, this one, you cannot do. Why? What is the range? Range is the largest and the smallest. They are different, right? Suppose you think about this. Okay. This one says the profit range must be $15. Okay. Then you can see this S star profit. Suppose you get AB. You can see AB, this range is 40. You add anything in, it will help or not. Remember, you said range must be 15. Here, this range is already 40. No matter what items you add in, you will never be able to reduce this range. Because these two items, the range is there. Okay? Unless you take them out, otherwise you add anything in, you will not help. So that means this range is anti-monotone. Right? Then I give you another example. I say this price greater than equal than B is not anti-monotone. What do you mean this? That means even you violate these constraints. Okay, you violate the constraints. Now, actually you add more things in, things may change. You may satisfy this constraint. That means you still have to go. This one you cannot throw it away. What does this mean? We're still thinking this one is $50. Okay. The $50, originally you add item A inside. A says $40. $40, this sum is 40. It's not greater than $50. Should you stop or should you go? You should go. Why? You think about this. Okay. Suppose this A is $40. Okay. I just say price. Of course, this one is a range. It's a profit. I just assume. Suppose this one, you get A is $40. You add in. Suppose B is $20. Originally you say $50. 40 is less than 50, but you want it greater than 50. Okay. You still can add in because you add B in, you get $60. So that's good. You specify this one. You actually can see this is very sensitive. Sometimes you dare to throw it in once it's wrong. Sometimes even it's violate the constraints, you still have to go. because in the future you have to set. That clear? Is that confusing? Okay. That means actually for computer, they are not as smart as a human. Okay. But you can actually just say this one, this constraint is anti-monotone, means any time it violates, you throw the whole thing away. Okay. That saves your mining cost. Okay. This one said not anti-monotone means you still have to go. Okay. Even it violates. Like now you said $50, and here it's only 40. And more. And more it will be 50. Right? So what's wrong? You still have to keep it and let it go. Right? So you treat them differently. Is that okay? Okay. The first thing is you have to understand this is the range. Range means maximum, minimum, their difference. Okay. You got it? Right. The difference means that once this difference is 40, it's violated your 15. No matter what you add in, the range is still only can be bigger, cannot be smaller. Right? So that's why this one is the range, not sum. The sum you can add, right? But range you can. Then the final one actually is just our very, very popular one. Says support is no less than the minimum support. Usually minimum support we write as a sigma. This is different from standard. Same Greek letter. Okay. This one actually is anti-monotone. That's why, you know, once you violate this, you don't have to go. Okay, you think about this. Why we can use apple? Why we can thinking this apple is a knife, you can cut things? Just because this apple, this contains actually is anti-monotone. Anti-monotone means once you get this support, suppose you get beer and diaper getting together. Okay, they are frequent, but if you add nuts, they become infrequent. You don't have to go anymore. Because if they become infrequent, you get anything in, it still will be infrequent. That's why you can cut. That's why the a priori pruning, the a priori algorithm works. That's why the FP growth works. Just because this minimum support is anti-monotone. Anti-monotone means once this one is smaller, you will never be able to go ahead. You add anything, it still be smaller. It will still be less frequent. Then you can cut. Right now you can see these anti-monotone is exactly like an apple you can use in the same way. Is that clear? That means actually this apple not only apply to this one, to any anti-monotone constraints you can use the same way as apple. Once they do not satisfy, let this data go. Let this pattern go, because this pattern will never be able to satisfy by adding anything in. Right? So this anti-monotone is a very useful knife. Is that clear? Okay. Now we give you another constraint called monotonicity. Monotonicity actually is a similar as you learn in most math class. Monotonicity is once you satisfy these constraints, you add anything, is still satisfied. That's monotonicity. Okay. So I still give you the example if you can see what's going on. The example means this. Okay. Suppose I have this sum S dot price greater than $100. This would be, we still say 50. Suppose it's $50. I say this one is monotone. Monotone means what? Means here you can think about this. This item said you add something in, the sum of the price is greater than $50. There you add anything in? More? Of course, you know, because you said you want to get a $50. You want more than $50 or 50 or more, right? If you add this thing in, you say now it's $50. Dare you add anything more? Sure, you just add it because you said over $50. I can anything in and still over $50, right? You can see that. But what's the use of it? The use of it is once you satisfy the monotone, you don't have to check this constraint. Because you think about this. Once I added this water in, okay, this bottle in, say this is $50. There I add this one in, sure. Do you need to check it? No. Why don't I have to check it? Because you said over $50. Now it's over $50. You add anything more in, it's still over $50. Why I have to keep checking it, right? So this usefulness is once it's satisfied, you don't have to check constraint. You can drop this constraint because this constraint will always satisfy. Right? So that's monotone. Like this one. Can you check whether this one is monotone or anti-monotone? You can see. This one, minimum price is less than. This one is monotone in the sense, okay, suppose you say, I want to get something in my basket, the minimum is less than $5. You put, suppose this one is $5, less than $5, you put it in your basket. Okay. Do you need to check it again? You don't need to check it again because your basket contains this bottle is less than $5. Okay. No matter what things I add in, the minimum one is still less than $5, right? So I don't need to check it. So that means this monotone has a nice property is once this bag, this item set, satisfies this constraints, you don't need to check anything anymore because as long as I don't steer anything out, right? You add anything in, it still satisfies. So that's anti-monotone. Like this one is also anti-monotone. You can see this. The range of the profits is greater than $15. Once the range is greater, you add anything in, positive or negative, you add anything in, the range is still greater than $15. So you don't need to check it, right? So you actually can see there's some magic. The magic is, if you watch this, both of them, you actually can see you flip the greater than to smaller than or smaller than the greater than one. One becomes anti-monotone, one becomes monotone. That interesting. That means sometimes you put a constraint, you have to watch out. Some is monotone, some is anti-monotone. Anti-monotone is a knife to cut. The monotone means once you satisfy, you don't have to check it, but you don't have a knife to cut it. Right? So that's the second about a monotone. You can see what we really want to find is a knife. The knife can cut your mining cost. Right? It's more like when you insert a car. Why the bank can quickly give you the money? Because they have a constraints on your ID. They can confine the data sets. Now we come down to a little trickier part. Previously we are looking for the patterns. Now we go back to look at the data. That means I can have knife cutting on two things. One thing is I can cut a pattern. The cut pattern means while you grow this pattern, as you don't grow anymore, it's hopeless. You go. Okay. So that's a cutting pattern. This is the knife cutting data. That means originally data is very big. Now you say, oh, those transactions useless. Throw it away in my pocket. And if I throw a lot of data, my data need to mine the subsequent iteration will be much smaller. So it's still benefit. How can I cut the data? Now you look at the original monotone, anti-monotone is on the patterns. This one is on data. We give it more clear. We say data anti-monotone. The other one is pattern anti-monotone. This one is data. That's the difference. What is data anti-monotone? You look at this. I give you an example, then I explain the definition. Because otherwise you feel it's just too boring. Let's look at this. This one said sum of the profit is greater than something. Suppose this something is $25. Then this one says sum of this profit is greater than $25. And we know this one is not a patent anti-money, because you know once you put something in, if it's less than $25, you still can put something more in, right? So that's not a constraint. But you can look at the data. You say, what about I cut data? Instead of, I know I cannot cut my item sets because item set is not anti-money. What about I look at the data? I can cut data. That's also good, right? So let's look at this to see whether it can cut data. Let's just look at this to give you a little concrete. You look at the concrete data. Here we can look at this. Okay. So I look at 10, I look at 20, I look at 30. I look at those transactions to see whether it can cut. Suppose you can think about it. You got a C, suppose, in your basket already. That means when you first mine it, you say C is frequent, I grab C out. Okay. And we know C is minus 20. That means this is like a banana, right? You sell 2 cheap. Okay, I grab it, you lose $20. Okay, this 20 means you buy C, the store lose $20 here. But of course, the store wants to get more profit. Okay. What you want to see is, suppose you want the sum of the profit is greater than $25. That means I really want to find those things, those item sets, is greater than $25. Then I think I can make money. So then, how do you see whether it's there to mine? Here you put you put C there. You know C is minus 20. There are lots of ways to grow to get into over 25. But the interesting thing is, okay, you look at this A, and this BDFH. Okay. You get an A there. But you look at it. Suppose you get a C. You look at C here, you project this, and this 40, you look at this 40. 40, get a C, you get an A, E, F, G. Okay. And what you can see here is, suppose you project C's project database, you get 10, 20, 30, and I probably should say here, they should have a 40 there, right? Let me see why there is no 40. A, E, F, G. A, E, F, G. It seems the 40 should be there. I will go back and check it, okay? But anyway, let's look at, suppose you get a 10, 20, 30 there. Suppose these are 3 projected databases. I actually still wonder why there is no 40. But anyway, suppose you get this. What you can see here is among these items, A is infrequent. You can cut it because it appears only once. You cut it. Once you cut it here, one thing you can see for 30 is this. 30 has a BDFG. What is BDFG? BDFG, these several things. What you can see could be this. This one is already minus 40. You add everything here, BDFG, you add everything here, you will never be able to make 25. Is that true? You can think about this. This is B, this is D, this is F, this is E. G actually is 20. 20 and 20, you get 0. But all the others, BDFG, you add a BDF together, BDF, they are all negative or 0. So you will never be able to reach 25. That means even you put all these things into your shopping transactions, that means suppose every item is frequent, you put everything in, this one will never be able to reach $25 profit, right? That means this transaction never be able to contribute to your successful mining. Is that true? Since you'll never be able to contribute to successor mining, this one should be gone. Right? That means actually T30 can be removed since none of them can make S, whose sum of the profit is greater than 25. That means I know this one I cannot cut on the patent side, but I can cut on the data side. It means if you look at this one, you actually can see this one is gone. If this one is gone, there are more things can be gone, right? Because you look at the frequent things, maybe something not frequent, you can cut. And then you can check it again. You say, oh, the remaining one can never reach it. You can cut more. That means quickly you can reduce your data sets. With this constraints, you can reduce your data sets down to the very minimum. Right? So that one is we call data anti-monotone. Data anti-monotone means this. I can read it. If a data entry T, that means if this transaction cannot satisfy a pattern under C, this C is your constraints. The T cannot satisfy P's superset either. That's why we should cut this T. Is that clear? Maybe a little confusing, but it's true. That means, remember we have two knives. Okay? One knife is cut pattern, the other knife is cut data. How to cut data? You look at every transaction. Okay? That means while you mine it, remember once you say, I mine C, I got C's project database. Once I got C's project database, I can check if these remaining data sets can never satisfy my constraints. Let it go, because you'll never be successful. You add in only damaged things will never make it successful. Why have to mine this part? So this part is good. Is that clear? Of course, you know, you may think this is a little confusing. You need to read this again. That's fine. Because almost any of this kind of constraints, like one or two sets of constraints, is a research paper generated by a PhD. Okay, that means almost half of the PhD thesis is working on this, and finally you find this one is very useful. Okay, they put it down. It's a research. Of course, that's a research paper more than 10 years ago. Now it becomes common sense. But at that time, people found it. They found it very exciting. Okay. Now we look at the others. Okay. Actually, you can reason this one is data anti-monotone. This one is also data anti-monotone. Actually, data anti-monotone, you will find a lot of them are data anti-monotone. You actually can cut data in an aggressive way. Okay. So you can look at this one, why it is anti-monotone. I can reason on it. Okay, you both can look at this. I say this one. Anti-monotone means you got the current pattern. Okay. This price, you get a minimum, is less than V. But now, suppose you got your data is greater than V. Okay. So let's say this. Okay. Suppose your basket is already greater than V. Okay. Then you look at the remaining data sets, actually you can cut it. And on the other hand, if this one does not violate the constraints, your data violates the constraints. Just thinking about this. Suppose I got a very rich guy. Okay. He come there, he buy all the stuff is over $100. Suppose you go to Macy's, buy everything. Every single item is greater than $100. Okay. Now, if you go down there, you say minimum of this one, the price must be less than $5. Do you need to look at this rich guy's transaction history? No, because anything he bought in his shopping basket is over $100. This one is say less than 5. You won't be able to find it. That means if you go down your data sets, you look at it, you find that the remaining of your transaction in all these items cannot satisfy this constraint. then this transaction can be gone because you will never use it. Every item is over your minimum price already. Okay? So don't look at it. Throw this transaction. This is more like this average guy. Let it go. I don't look at it because you want a minimum price is less than $5. I won't find it. So this one can cut things in the middle, can cut things in the beginning, also can cut things in the middle. What do you say cut things in the middle? Okay. Suppose you bought something. Okay. I probably should finish this quickly. We just finished. Suppose you got something right in the middle. You say the first thing is I mind this thing. I got my shopping basket. Maybe this one is some kind of electric stove, suppose $20. I still want to put more things in. Okay. I just look at the remaining one. The remaining transaction, okay, the frequent items, is anything you start chopping something, the remaining thing cannot satisfy it. The whole thing is also gone. Okay, you can see that's the one. This transaction is not like the whole transaction. It could be just the remaining part of it. So you still can cut it. So anyway, I know somebody may not fully understand all those constraints. That's why I think we need a Tuesday lecture to finish this one. Once we finish this one will be good in your midterm exam. Okay. So you still need to come to the Tuesday lecture if you want to do well on this part. Okay. Thank you.